Today we are start with our last semester of BSc program. This chapter is electrochemistry, which you have studied in plus 2 classes. But here you have two separate chapters for electrochemistry. They are electrochemistry 1 and electrochemistry 2. Electrochemistry 1 deals with electrolytic cell, and second unit discuss about galvanic cell, that means electrochemical cell. What you mean by the term electrochemistry? Important points which we have to cover in this topic can be summarized as below. What is electrochemistry? What's an electrolyte? What you mean by the term electrolysis? Discuss the mechanism of electrolysis. You have heard about Faraday's laws of electrolysis, first law and second law. All these things you may have studied in physics also. Comparison of metallic and ionic conductors. Factors affecting electrolytic conduction. What is molar conductance? What to mean by equivalent conductance? What is the meaning of the term specific conductance? How lambda m, that means molar conductance, lambda eq, equivalent conductance, and kappa, specific conductance, vary with dilution. Arrhenius theory of electrolytic dissociation. It is a new concept to you. This was not there in your plus 2 classes. Ostwald dilution law, that you have studied in ionic equilibrium. Debye-Huckel theory. Transport number and its determination. Applications of conductometry. These much of subtopics we have to discuss under this electrochemistry 1. We can discuss one by one. First, what is electrochemistry? You have heard about electrochemistry, nuclear chemistry, polymer chemistry, and different fields of chemistry. Here, in electrochemistry, we are discussing the interrelationship between electrical energy and chemical energy. Electrical energy and chemical energy are two different forms of energies. One can be converted to other. For this interconversion, we are using two kinds of cells. They are electrolytic cell and electrochemical cell. Electrolytic cell and electrochemical cell. In electrolytic cell, we have direct redox reaction. But here in electrochemical cell, indirect redox reaction. Here in electrolytic cell, no need of salt bridge, but here salt bridge is essential. Third one, Charge of the cathode and anode. In electrolytic cell, cathode is negatively charged and anode is positively charged. While in electrochemical cell or galvanic cell, we have cathode as positive charge and negatively charged anode. The most significant difference between them is first cell, electrolytic cell, used for electrolysis. Electrolysis means electrical energy we are supplying, and as the result of the supplied energy, chemical reaction takes place. Or simply, we can say that electrical energy is converted to chemical energy. But here, chemical reaction takes place and electrical energy is generated. That means chemical energy is converted to electrical energy. Now we have to compare the ionic and metallic conductors. Ionic conductors is also known as electrolytic conductors. Metallic conductors are also known as electronic conductors. Electrons, then electronic conductors. So we have to compare metallic and ionic conductors. Metallic is also known as electronic. Ionic conductors are electrolytic conductors. In metallic conductors or in metals, conduction is due to the flow of free electrons. While in electrolytic conductors, it is due to the flow of ions. There we have free ions in the solutions, which are responsible for they are the carriers of electricity. In a metallic conductor, there is no chemical change. But chemical change is there in electrolytic conductors. For example, when electricity is passed through molten NaCl solution, this NaCl will split into Na plus and Cl minus, and Na plus move towards the cathode and deposit as sodium, and Cl minus move towards the anode and deposit there as chlorine. Here Na plus ion in solution get reduced to sodium at the cathode, and Cl minus ions in solution get oxidized and then liberated at anode. There is reduction for sodium and oxidation for chlorine. So chemical reaction takes place in electrolytic solution. But in a conductor, for example, if you take copper wire, even if we are passing current for hours and hours or years and years, there will be no chemical change. Copper will never changes to copper 2 plus, or copper will never changes to copper sulfate or copper oxide or any other forms. There is no chance of chemical change. Third one, no transfer of matter is possible in metallic conductors, but transfer of matter is possible in electrolytic conductors. That is also there in the previous example of the story of molten NaCl. When molten NaCl is electrolyzed, sodium from the solution completely transferred to cathode and Cl minus discharged at the anode. So there is a transfer of matter towards the cathode and anode, but there is no chance of such transfer in metallic conductors. Then conductivity decreases with increase in temperature. This is the story of metallic conductors. But the case of electrolytic conductors is different. There conductivity increases with increase in temperature. Here it is decrease, here it is increase. How? You have heard it. As far as concerned with metallic conductor, metallic conductors are considered to be positively charged metal ions and free electrons. Here Metals are considered to be made up of positively charged kernels. They are immobile and immersed in a sea of free electrons. ഫ്രീ ഇലക്ട്രോൺസിൻ്റെ ഒരു വലിയ കടലിൽ അനങ്ങാൻ പറ്റാത്ത രീതിയിൽ ആരുണ്ടാവും? പോസിറ്റീവ്ലി ചാർജ്ഡ് കേണൽസ് ഉണ്ടാകും എന്നതാണ് മെറ്റൽസ് അല്ലെങ്കിൽ മെറ്റാലിക് കണ്ടക്ടേഴ്സ് എന്നതിൻ്റെ അർത്ഥം. ഇവിടെ കറണ്ട് കണ്ടക്ഷൻ്റെ കാരണം തന്നെ ഫ്രീ ആയി മൂവ് ചെയ്യുന്ന ഈ ഇലക്ട്രോൺസ് ആണ്. ഇനി നമ്മൾ ടെമ്പറേച്ചർ ഇൻക്രീസ് ചെയ്യുന്ന സമയത്ത് ഈ കേണൽസ് ആക്ച്വലി ഇമ്മൊബൈലാണ് അല്ലെങ്കിൽ സ്റ്റേഷനറി ആണ്. ഇനി നമ്മൾ ടെമ്പറേച്ചർ ഇൻക്രീസ് ചെയ്ത് കഴിഞ്ഞാൽ എന്ത് സംഭവിക്കും? കേണൽസ് വൈബ്രേറ്റ് ചെയ്യാൻ തുടങ്ങും. ഈ കേണൽ വൈബ്രേഷൻ്റെ ഫലമായി ലെഫ്റ്റിലേക്കും ഈ കേണൽ റൈറ്റിലേക്കും ലെഫ്റ്റിലേക്കും വന്നാൽ ഭാഗികമായി ഇവർക്കിടയിലുള്ള ഈ വഴി അടയും. ഈ പാത്ത് പൊതുവെ കുറയാൻ തുടങ്ങും. അങ്ങനെ വന്നാൽ ഈ ഇലക്ട്രോൺസിന് മൂവ് ചെയ്യാൻ പറ്റാതാവും. ഇപ്പോൾ ഡ്യൂ ടു ദി ഇൻക്രീസ് ഇൻ ടെമ്പറേച്ചർ കേണൽസ് വിൽ വൈബ്രേറ്റ് വിച്ച് റെഡ്യൂസസ് ദി പാത്ത് ഓഫ് ഫ്രീ ഇലക്ട്രോൺസ്. അങ്ങനെ ഇലക്ട്രോണിന് മൂവ് ചെയ്യാൻ പറ്റാത്തൊരവസ്ഥയിലേക്ക് വരുമ്പോൾ നമ്മൾ അതിന് സാധാരണഗതിയിൽ പറയുന്നത് മെറ്റലിൻ്റെ റെസിസ്റ്റൻസ് കൂടി എന്നാണ്. ഇപ്പോൾ ടെമ്പറേച്ചർ കൂട്ടിയാൽ റെസിസ്റ്റൻസ് കൂടിയാൽ കണ്ടക്ഷൻ കുറയും എന്നാണ്. അതേസമയം നമ്മൾ ഇലക്ട്രോലൈറ്റിൻ്റെ ടെമ്പറേച്ചർ കൂട്ടിയാൽ, അതായത് ഇലക്ട്രോലൈറ്റിക് കണ്ടക്ടറിൻ്റെ ടെമ്പറേച്ചർ കൂട്ടിയാൽ അവിടെ എന്താണ് സംഭവിക്കുന്നത്? ടെമ്പറേച്ചർ കൂട്ടും തോറും ഇലക്ട്രോലൈറ്റിക് സൊല്യൂഷൻ്റെ വിസ്കോസിറ്റി കുറയും. വിസ്കോസിറ്റി കുറഞ്ഞാൽ സ്വാഭാവികമായും അയോൺസിന് മൂവ് ചെയ്യാനുള്ള ടെൻഡൻസി കൂടും. രണ്ടാമത്തെ കാര്യം, ടെമ്പറേച്ചർ കൂടുന്നതനുസരിച്ച് അയോണിൻ്റെ കൈനറ്റിക് എനർജി കൂടും. കൈനറ്റിക് എനർജി കൂടിയാലും എന്ത് കൂടാം? മൊബിലിറ്റി കൂടാം. ഇപ്പോൾ രണ്ട് കാരണങ്ങൾ കൊണ്ട് അവിടെ അയോൺസിൻ്റെ മൊബിലിറ്റി കൂടുന്നു, അതുകൊണ്ട് കണ്ടക്ടിവിറ്റി കൂടുന്നു. അതേസമയം മെറ്റലിൽ ടെമ്പറേച്ചർ കൂട്ടുമ്പോൾ അവിടുത്തെ കറണ്ട് ക്യാരിയേഴ്സായ ഇലക്ട്രോണിൻ്റെ മൂവ്മെൻറ്റ് കുറയുകയാണ് ചെയ്യുന്നത്. സോ ദർ ഈസ് എ ചാൻസ് ഓഫ് ഡിക്രീസ് ഇൻ കണ്ടക്ഷൻ. നൗ വി ആർ കമ്മിങ് ടു ഇലക്ട്രോളിസിസ്. ഇറ്റ് ഈസ് എ പ്രോസസ് ഓഫ് Example, electrolysis of NaCl. We have to take molten NaCl in a rectangular vessel. Two platinum electrodes or inert electrodes are placed in it. Negatively charged electrode is called cathode, positively charged electrode is called anode. In molten NaCl, we have two ions, Na plus and Cl minus. Na plus move towards the cathode and deposit through reduction. Na plus plus 1 electron gives Na. And Cl minus move towards the anode and liberated as chlorine gas through oxidation. This is reduction, addition of electron. This is oxidation, removal of electron. This is what? The process of electrolysis. Here, sodium chloride is dissociated by passing electricity. So, we can consider sodium chloride as an electrolyte. What is the mechanism of electrolysis? we have to take molten NaCl as example. Molten NaCl. How to prepare molten NaCl? That is the first question. It is very simple. Solid sodium chloride is heated above its melting point. Then it will become a liquid. That molten liquid is taken. That molten NaCl, that solution contain Na plus Cl minus. Using two platinum electrodes, we have to pass electricity. Then, as we discussed in the previous slide, we can see that Na plus accept one electron and undergo reduction to sodium. Metallic sodium is deposited at cathode, and at anode 2Cl minus gives Cl2 plus 2 electron. This is the reaction in molten NaCl, but in aqueous NaCl, picture is different. Aqueous NaCl can be prepared by dissolving NaCl in water. NaCl in water. On passing electricity, NaCl dissociates as Na plus Cl minus, and water also split as H plus OH minus. Here we have two cations and two anions. So the condition is more complicated than the previous case, because here we have two cations and two anions to get reduced at cathode and get oxidized at anode. So there is a question, who will be discharged first? Since the reduction potential of hydrogen is greater than sodium, or discharge potential of hydrogen is greater than sodium, hydrogen ions will move towards the cathode. 2H plus 2 electron gives H2 liberated. At anode also there is a competition between Cl minus and OH minus, but due to low discharge potential, Cl minus move towards the anode and discharged as chlorine gas. Reduction at the cathode and oxidation at the anode. Here we have sodium at the cathode, but here we have hydrogen at the cathode. Because of higher reduction potential of hydrogen or lower discharge potential of hydrogen. Both terms can be used. Cl minus is same in both cases. Anode Cl. After the removal of H plus as hydrogen and Cl minus as Cl2, our reaction vessel contain NaOH. So this is the process of preparation of sodium hydroxide, Nelson cell process. Another electrolyte is copper sulfate. It can be electrolyzed using inert electrode. Or copper electrode. Copper sulfate when electrolyzed using inert electrode like platinum. Then copper sulfate split as Cu2 plus SO4 2 minus. Water split as H plus OH minus. At cathode, again we have a competition of H plus and Cu2 plus, but because of higher reduction potential, copper 2 plus, you have to check it in electrochemical series. Copper possesses higher reduction potential. So Cu2 plus will accept 2 electrons from the cathode and deposit it as copper. And at anode, we have sulfate and OH minus, but OH minus migrate towards the anode. 4 OH minus gives 2H2O plus O2 plus 4 electron. This is the reaction at the anode if we use aqueous copper sulfate using inert electrode. Instead of inert electrode, we can use active electrode. If we use the copper electrode instead of platinum, we can use copper electrode for the same process. Then we have Cu2 plus SO4 2 minus Reaction vessel is like this. We have copper sulfate solution containing H2SO4. Here we have copper electrode. Here also we have copper electrode. Here it is negatively charged cathode. It is positively charged anode. Reaction vessel contain copper sulfate Cu2 plus and SO4 2 minus. Here what actually happens is that Cu2 plus ion from the solution get discharged at or deposited at the cathode. Cu2 plus from the electrolyte reduced and deposited at cathode. As the process continues, concentration of Cu2 plus will diminish in the solution. When Cu2 plus ions move towards the cathode and deposited there, definitely there will be a decrease in the concentration of Cu2 plus in the solution. To compensate that decline in the concentration, copper from the anode dissolved in solution. Copper from the anode dissolved in solution as Cu2 plus. So at anode, copper atoms ionizes to Cu2 plus 2 electron. These Cu2 plus dissolved in solution also have the positive charge. They are attracted towards the negatively charged cathode and they will be reduced at the cathode. Or simply the copper atoms from the anode move towards the electrolyte and deposited finally at the cathode. Here we can see the transfer of matter from anode to cathode. This process we have studied in metallurgy for the purification of copper. It is pure cathode. Anode is impure cathode. From the impure cathode, copper atoms only deposited at the anode. The remaining nickel, silver, gold, etc. will deposit in the bottom of the container. Copper only deposited at the cathode. In this way, copper can be purified. Net reaction. What is the net reaction? Anode reaction plus cathode reaction. Cu cancelled. Cu2 plus is also cancelled. Electron is also cancelled. So net reaction is 0. What is a net reaction? Here there is no chemical reaction actually happen. Here we can see the transfer of matter from anode to cathode.